Hi everyone. We're going to go ahead and talk about how to factor special cases of polynomials. So the first one we're going to talk about is how to factor perfect square trinomials. Now, a square, of course, is any number that has resulted from multiplying a number by itself. For example, 4 times 4 is 16. 16 is the perfect square. Well, in polynomials, it's the same thing, only it's two binomials multiplied that are the same multiplied together. So with perfect square trinomials, it's actually really easy to factor. So we see here we have a squared plus 2ab plus b squared. Now, if you remember from the factoring video, a, b, and c from that video were our coefficients to our expression. In this case, a is and b are the entire terms, so we need to keep that in mind. Notice it's a little a and a little b, not a capital A and a capital B. So first of all, when you have perfect square trinomials that have a positive middle term, that's this term right here, we always have a factor. It's always going to factor to a plus b quantity squared. Now, if you have a perfect square trinomial that has a negative middle term, it's going to be the opposite. We're going to have a minus b quantity squared. Perfect square trinomials will always have a positive first term and last term because there's no way to multiply a number by itself and get a negative number. So the first example we have here is 4x squared plus 24x plus 36. So it says step 1, take the square root of the a squared value. So we have 4x squared. So the square root of 4 is 2, and the square root of x squared is just x. And then we have the square root of 36, which is 6. And it asks you whether the signs of the factors will be positive or negative. Since 24x is positive, our factors will be positive. So our answer is going to be 2x plus 6 quantity squared. Now next we have 9x squared minus 48x plus 64. So the first two steps are exactly the same. 9x squared, the square root is 3x. The square root of 64 is 8. And this is going to have a negative in the middle, a minus. So we're going to have 3x minus 8, close parentheses, and quantity squared. And that's all there is to factoring a perfect square trinomial. Now, perfect squares are not the only polynomials that are considered special cases. We also have the difference of two squares. Now, that is going to be represented as a binomial with two perfect square terms that can be factored. So we have a squared minus b squared here. And the way that's going to factor is the first thing you should do is go ahead and draw two sets of parentheses. The first one can be plus, and the second one will be minus. And we're going to have a plus b and a minus b. Now, it doesn't matter, of course, which one's plus, which one's minus, because multiplication is commutative. That means it doesn't matter what order you put the factors in. Now, the first example we have here is the factor 25x squared minus 81. And it does say, if possible, factor out any common factors. In these ones that we have here, none of them have any common factors. So what we'll do is we will go ahead and show you a few examples as well. So step 1 is find the square root of a. So we have 25x squared, and that factors to 5x. And we have 81, and the square root of 81 is 9. And then all we do is fill in the blanks. 5x plus 9, 5x minus 9. Now, the next one we have is 16x to the 4th minus 49. Now, whenever we see an exponent that is an even number, it is a perfect square. 2, 4, 6, 8, 10, 12, etc. All you have to do is divide the exponent by 2 to get the square root. So the square root of 16x to the 4th is 4, which is the square root of 16. x to the second, or x squared, which is the square root of x to the fourth. And of course, the square root of 49 is 7. So we're going to have 4x squared plus 7 and 4x squared minus 7. Not difficult at all. So we're going to have a couple of examples. Now we have A. See, it's a trinomial. That means there's 3 terms. So we're going to need one set of parentheses and a square. And we know it's going to be positive because our 6 here is positive. So we're going to put a plus. The square root of x squared is just x, and the square root of 9 is 3. So this one factors to x plus 3, quantity squared. Now we have 4x squared minus 36. So again, this is a difference of 2 squares, so first thing we should do is draw 2 sets of parentheses. One is positive, one is negative. We have 4x squared, so that factors to 2x times 2x. And the square root of 36 is 6. Simple as that. Now we have C over here, which is 9x squared minus 64. And again, 2 sets of parentheses because it's a difference of 2 squares. And this time I'm going to go ahead and put minus in the front and positive in the second one, just to show it doesn't really matter. So we have 3x and 3x because 3x is the square root of 9x squared. And then we have 8, which is the square root of 64. And then finally we have the option D, which is 4x squared minus 44x plus 21. We see that the 44 is negative, so we're going to make one set of parentheses with our squared, and we're going to put a minus in there. And then the square root of 4x squared is 2x, and then the square root of 121 is 11. Now, many people have asked me before, why does this work with the difference of 2 squares? And it's very simple, actually. So let's take 4x squared minus 16. That's a simple one. So we're going to go ahead and multiply. We'll go ahead and factor it, and then we'll multiply. So plus and minus, we have 2x plus 4 and 2x minus 4. So when we multiply polynomials, we're going to do our double distribution, or what's popularly known as FOIL, first, outside, inside, last. So we're going to take the first term and multiply them together. 2x times 2x is 4x squared. 2x times negative 4 is negative 8x. 4x times 2x is positive 8x. And 4 times negative 4 is negative 16. Now, you see we have a negative 8x plus 8x. When we have two terms that are the same but opposite signs, they add up to 0x. And we don't have to write zeros, so we just leave it with 4x squared minus 16. And that's all the reason why that works. Now, the problems are not always quite this simple. Sometimes we don't know that we have perfect squares available to us, and sometimes we're given information that tells us that it's a little bit more difficult. So let's take another example. We have 100x to the fourth minus 16. And these are two perfect squares. We can factor this to 10x squared minus 4 and 10x squared plus 4. And that is a perfectly respectable answer. However, what if you were told to factor completely? Now, this, like I said, 10x squared plus 4 and 10x squared minus 4 are factors of 100x to the fourth minus 16. But to have the best factorization, the most complete factorization, we're going to need to factor out a common factor. So if I take 100x to the fourth minus 16, and I divide both of them by 4 so I can factor out this common factor, I'm going to put a 4 here outside of parentheses. And 100 divided by 4 is 25. And we're not going to do anything to the x, so we're going to have x to the 4th. And 16 divided by 4 is 4. Now 25 and 4 are also perfect squares. So the most complete factorization of 100x to the 4th minus 16 is 4 times 5x squared plus 2 and 5x squared minus 2. And that would be the complete factorization of this particular problem. Now, finally, we also will have problems where they're not perfect squares to start with. So let's take this one. We have 18x squared plus 60x plus 50. None of these are perfect squares. 18 is not a perfect square, 50 is not a perfect square. However, what we do know is that 18 and 50 are both divisible by perfect squares, and when you divide by their perfect squares, you get the same factor. So let's say we divide everything by 2. 2 is a common factor for 18, 60, and 50. So what I'm going to do is I'm going to write that 2 I was dividing by on the outside of a set of parentheses. And 18x squared divided by 2 is 9x squared. 60x divided by 2 is 30x. And 50 divided by 2 is 25. And now that we look at it, we can see 9 is a perfect square, x squared is a perfect square, and 25 is also a perfect square. So we're going to factor our perfect square trinomial here. The square root of 9x squared is 3x squared. We're going to put a plus sign because our 30x is positive, and the square root of 25 is 5. And then, of course, we're going to put our exponent of 2. So we have 2 times 3x squared plus 5 quantity squared, and that gives us our most complete factorization of 18x squared plus 60x plus 50. All right, so if you have any questions, feel free to leave them in the comments below or on our Google Classroom. And if you want to be notified about when I update a new video, go ahead and click that bell icon and subscribe. That way you can be up to date on all the most recent lessons. Bye!